Hello guys, so we are going to continue a discussion with respect to the vector multiplication, and in this video we are going to talk about scalar multiplication. Now what exactly is scalar multiplication? So it involves multiplication, it involves multiplying vector by a scalar, okay, resulting in a vector where each component is scaled by the vector. Okay. Now let's go ahead and see some basic example, and then we'll try to understand it. Okay. Now for this, let's say that I have a vector A, and let's consider it as 3-dimensional, 3, 5, 7. Okay. And here we will initialize a scalar value C, let's say, and this particular value is like 4. Okay. Now, what is basically happening over here is that when we say scalar multiplication, we are basically multiplying this particular scalar value with this vector. So once we multiply the scalar value, let's say if I go ahead and write C and A, in short, we are basically multiplying the scalar element with all the values that are present inside this vector. So this will basically become 12. This will actually become 20, and this will become 28. Okay. So here you will be able to see these values, right? So this will basically be my final scalar multiplication. Now it is important for you all to understand how does this look in the coordinate system also. So here, if I have this coordinate system, and let's say this is my X and Y coordinate, let's consider a vector. Here I will take a single dimension. Let's say it is 2, 2. And here I will take my vector as 2. Okay. So this is nothing but 1, 2, 3, 4, 5. Here also I'll get 1, 2, 3, 4. Okay. So this is my Y coordinate. Now in order to show you this 2, 2, where exactly this vector is, this vector will be present over here, right? And this is the direction of this particular vector. Now as soon as we multiply this vector, this scalar 2 to this vector, what is basically going to happen? Let's say if I'm multiplying with 2, that basically means this vector with respect to X and Y coordinate will also getting increased 2 times. So this will finally go towards 4, 4, right? So this is what the values is, the vectors are basically getting extended back by that many number of times, which is represented by the scalar value, right? We are just extending this particular vector to that particular direction by that many number of units. Okay. So this is just an example with respect to scalar multiplication and how does it look in the coordinate in this particular coordinate system. Okay. Now let me just go ahead and talk some of the examples. You know, there is something called as normalization and standardization. Now let me go ahead and talk about this normalization and standardization. What does this basically mean? Okay. And in normalization or standardization, we will be scaling the data to some units. Scaling the data into some units. Okay. Why this scaling will be necessary? I will talk about it. Okay. So let's consider one example. Let's say that, hey, I will just take an image. Okay. And this will basically be a grayscale image. Okay. And this image is basically having 4 x 4 pixels. This is how every image is represented, right? When I say 4 x 4 pixels, that basically means every pixel will be ranging between 0 to 255. And this is what determines the color, right? In the grayscale, 0 to 255, right? When I say grayscale, there is only one channel. When I say it is a colored image, I basically talk about it is having RGB channel. Okay. Now in this scenario, you know, your pixels value are very high, right? Now, let's say that if I want to probably do an image processing, it is always a good thing that we normalize this image values, normalize the pixel values. the pixel values between 0 to 1. Let's say I want to go ahead and normalize this into 0 to 1. Why? Because in image processing also we really need to do a lot of calculation, and I don't want any big numbers over here. So what we can do is that we can normalize all these pixels between 0 to 1. How do I normalize it? I will take every pixel in this, and I will try to divide by 255. Let's say if I go ahead and divide every pixel by 255, this is going to get converted into between 0 to 255, 0 to 1, right? I'm just going to divide each and every pixel by 255. And this process is basically called as normalization, okay? Let me talk about one more thing. Let's say that I have a feature. Let's say over here, I have a feature. Let's say I'm solving a machine learning problem statement. I have a feature which is represented, or let's say that feature name is height, and we'll consider this as a vector, okay? And this height is nothing but 160, 170, 180, okay? This is a vector, okay? Now let's say that I want to convert this height or scale this height to meters, okay? Now if I want to scale this, what I have to basically do, let's say that I will take a scaling factor 0.01, okay? And then I will take this height and I'll multiply with this scale. So I'll write CH is nothing but I will multiply 0.01 with 160, 170, 180. Again, this units can change. It is up to you. So now if I go ahead and get it, I'm going to get that 160 centimeter is nothing but 1.6 meter, right? And that is the reason, see, when I probably say 1 centimeter, it is nothing but 0.01, right? Meter. So that is the reason I'm trying to multiply all the centimeters with this value. So now I'm going to get 1.6 meters, 1.7 meters, 1.8 meters. So in short, we have just done some scalar multiplication in order to scale some values into a different scale, right? Into different units. It can be in different scale, Why this is specifically done? This will be very helpful when we do specific calculation. And in that calculation, we require the dependencies of some other units, okay? So this was about the 3 types of multiplication that we do specifically with respect to vectors. We discussed about dot product, which we also say it as inner product, element-wise multiplication, and scalar multiplication. So yes, this was it from my side. I will see you all in the next video.